Hey there, ladies and gentlemen. Welcome to the Burma Nation. We're talking about the division properties of exponents. The last time we were hanging out, we were talking about the multiplication properties. So we're going to do some little bit different things, but pretty much the exact same stuff here. So this is 7-2. Your goal is to, at the end of this little video, say that I can use the division properties of exponents to simplify monomials. I think that should be a very accomplishable goal. Is that a word? Accomplishable goal? Accomplishable goal. Yeah, I think it's a word. So, big idea here is if we're going to be using division, instead of what we did on the last lesson of adding together the exponents, we're going to just subtract them. The way this works out is I'll make a real simple one here. If I had an x to the second power, which is the same thing as me saying x times x, over an x to the first power, it would look like this. And since x divided by x makes a 1, we just took them away. So we took 1x away and we're left with just x to the first power. So you're just subtracting. So if I have 11 x's on the top and 8 x's on the bottom, 8 x's from the top and bottom can simplify. So there's only 3 of them left over. So we just subtract. So here's the examples. Let's roll with this. I'll get some more page space here. There we go. Go extendo page. All right, so we're looking at the common terms where there's both x's here. So I'm going to have a 7 minus 6, which means there's going to be 1x left over on the top. And then I have a 12 minus 3 from my y's, which means I'm going to have a y to the 9th on the top, because 12 minus 3 is 9. So I just have a leftover answer of x, y to the 9th. So not too shabby. All right, on the next one, we're talking about the next property. The next, or I guess skill here, is to have a quotient, power of a quotient. So what we're going to do is we're going to have a whole fraction that is to an exponent, which means that each part, the denominator and the numerator, are going to end up with that same exponent. So if I have 3/5 to the 4th power, that means I have 3 to the 4th and 5 to the 4th. Because those things can simplify to these things, you would do so. So same ideas are going to happen in our example 2. I'm going to go green here, folks. So this 3 gets kind of pushed to all items, including the bottom. So I'm going to have a 4 to the 3rd. What was the number again? It was a 3rd, right? Yeah, let me erase it. Look, there we go. That looks super pretty cool. Then I have a c to the 3rd, so we're going to use yesterday's stuff. If I have a power to a power, that means I'm going to multiply, so that becomes c to the 9th. Power to a power, multiply again, so I have d to the 6th, because 2 times 3 is 6. And then over a 5 to the 3rd. The only thing that I need to still simplify in this specific problem is to do the math that's available there, which is 4 to the 3rd and 5 to the 3rd. Now I'm grabbing my calculator, my brain thingy that does all the work for me so I don't have to do all that work. And I'm going to do the 4 to the 3rd power, which is 64. I mean, I typed it into the calculator and that's what it told me. And I have c to the 9th and a d to the 6th. And then 5 to the 3rd power, I type it in the calculator, and I believe that's 120. I should probably check that. 5 to the 3rd, 5, caret button, 3, yeah, 125, good. Now, the only thing that I really want to make sure that does not happen here is that my 64 and 125 are not something that I can simplify. And I'm going to type it into the calculator as a fraction just to be safe. Even though I know what the answer is, I just want to kind of pretend like I'm doing stuff that you guys don't know about. Yep, and that stays as what it is, as 64 over 125. So this is the official answer because there's no variables that we can cancel out. All right, we got another rule for you. It's called the zero property of exponents. This zero property of exponents says that any number that's raised to the 0 power is 1. And here's a quick reason why. If I have a 2 to the 1st power, 2 to the 2nd power, 2 to the 3rd power, this is 8, this is 4, this is 2, and then 2 to the 0 power. So the relationship when I'm going from a bigger number to a smaller number is I divided by 2. That's one of the powers here. And I divided by 2 because that's what the base was. So to get from a 2 to the first power to a 2 to the 0 power, I would divide by 2 again. And since 2 divided by 2 is 1, that's why all numbers would be an answer of 1. So this whole crazy, silly work is 1. In example 3, all that crazy, silly work is 1. So there's not a whole lot of work that you have to actually do. If it wasn't there, you would subtract and get m to the third, and you have 3 n's on the bottom and 12 over 8. You'd simplify, but there's a 0 there, so pump the brakes. You got nothing else to do. It's just 1. All right, so let's check it out. They could look a little bit more complicated, even though this one doesn't look any more complicated, but we're going to do it anyway. And m to the 0 power is 1. So this is going to turn into a 1 times an n to the third over an n to the second. And we're looking at these things to simplify. If I have 3 on the top and 2 on the bottom, so that looks like this, I can cancel a grand total of 2 of them from the top and the bottom so that there's only an n left over on the top. And since there was a 1 over here times that 1n, so it just stays as the answer of n, or n to the first power if you wanted to write it. Now, here's the next big idea. Now, we're throwing at you a bunch of big ideas in this lesson, so stick with me here. Now, this one's talking about how we deal with negative exponents. So, if you look at it carefully, any number to a negative exponent just gets thrown to the bottom of a fraction and becomes positive. If it's on the bottom of a fraction that's negative, to make it positive, we just throw it to the top, is what this one says. So you just switch it from the top to the bottom to make it from being a negative to a positive, because, you know, it's crossing that positivity line. So, on this first example, the x to the negative 4, we're going to shove to the bottom of the fraction. The z to the negative 6, we're going to throw to the top of the fraction to get rid of those negatives. So it's going to be rewritten as a y to the 9th, z to the 6th, and then that x to the negative 4th turns positive by shoving it on the bottom of the fraction. So x to the positive 4th is now on the bottom. Because they're all different letters, it just stays what it is. Okay? Now I am going to ask you, ladies and gentlemen, to practice this one on your own. So again, you're going to move things that are negative from the top to the bottom, or from the bottom to the top. And this one's tricky with only, you got to remember to simplify that as well. All right, folks, this is the Birdman Nation. We just threw at you a whole bunch of stuff. If you need to pause, rewind, replay, whatever it is you got to do, you're going to want to check that out again. When we get this lesson in class, we'll again share with you some few things to make sure that we're all cool with it. But otherwise, this is how we deal with dividing exponents. This is the Birdman Nation, signing off.